All right. Hello, everyone. Welcome back to the Augmented Intelligence Workshop. It's my pleasure to host today's meeting, and we'll have Jerry Ju presenting on the collaboration of human and machine on creative problems, and Paul Smaldino will talk about social identity and social dynamics. So without further ado, I would want to invite Jerry to uh, take the stage.
Thank you very much. Thanks for inviting me. And it's great to be here, seeing old and new faces. So let me get this set up. Okay. Can people see the screen okay? All right, so the title is a little bit dramatic, but really what this is a attempt to use machine learning to help people in creative writing. So I came from a computer science department, and my background is in machine learning. So I'm going to, mostly talk about machine learning jargon, but hopefully the message will get through. The type of problem we're trying to address at large is the issue of creative block. And this, as we all know, happens a lot in occupations that requires creative thinking. But for this talk, for the sake of concreteness, we're going to just do word norming. We're going to study the problem of trying to come up with as many novel properties as possible within a short amount of time about a particular topic. And today's topic is penguins. So pretend we're in a situation where, I just ask you, hey, in 5 minutes, think of everything you can say about penguins. Right, so then we can start. So let me see if I can actually run a live demo. Can people see this screen?
Yep.
Oops, I'm sorry, I apologize. Actually the experiment timed out. There's a time limit, so I prepared it, loaded too soon, but that's fine. I have some screen captures, so let's actually work with that. So, okay, as I ask you the question of thinking of things to do with penguins, you might think, oh, they live on ice, so you may type that, and you think, oh, maybe they eat fish. So, okay, so you type that. Now, this can go on for a while, and we all know, like, we have maybe, 10, 20, 30 things to say about penguins as an individual. But very soon we start to run out of ideas, and the time is going to take us longer to think of new things. Now, as you can see in the interface, there's the notion of hint. This is where the computer, the AI comes in. The AI is going to somehow use words to prompt me and help me think of new things. So if I am the user and I sort of get stuck, I can click on that get hint button here. And then I want you to pay attention to the second line where you see the words ate, consumes, eat, buys, sleeps. These words are automatically generated by the AI based on what I have typed in previously. And we will get to how it actually did that. But the point is, here with those words, as a human, I look at them. Maybe I would say, oh, sleeps. I wonder how penguin sleeps. So that may inspire me to say things like, oh, penguin sleeps while standing up. Okay, so that's a new thing that I may not be able to think by myself. As another example, let's say I click this get hint again, and the AI is giving me seemingly random words: cell phone, safer, smallpox, rush, classifier, classifies and clarifies, and so on. Still, these might be useful. Like when I looked at these words, I was thinking, oh, smallpox, but I wonder what kind of disease would penguins catch? And that could inspire me to write a sentence like, oh, they can catch bird flu. So again, this would be something that I would not normally thinking of. So the talk is about the way that AI delivers these kind of hints. And I'm going to call them, in the following talk, I'm going to call them nudges instead. So the idea is AI will try to nudge me out of my creative block. Now, just to be clear, right? So we all know, like informally, there are so many different ways you can be nudged. You can watch a movie, you can listen to music, take a hot shower, and so on. And these are all valid interventions. But for computational reasons, I'm going to restrict the type of nudges just to be, English. So these are going to be words or sentences. Still, as you saw just now, there actually could be many different ways AI can nudge me. So I'm going to present a couple ideas, and the whole list goes on for quite a while. But the first thing that one might think of is maybe the AI can do something like find synonymous words to the ones I have already said. So for example, if I said penguins live on ice, the AI could latch onto the word ice, and then AI has, has access to whatever semantic embedding space, say word embedding, right? So it can go there and look for nearby words, and maybe it will see like snow is close to it, hockey is close to it, water, icy, frozen, etc. So it could use these words to prompt me. And the idea might be like, oh, I as a human, I'm thinking around the topic of, ice and so on. So maybe these nearby words will help me further think, develop that pocket of semantic space. So that's one natural idea. But if you take this a step further, and obviously, maybe it's a good idea to nudge me by jumping to a different part of the semantic space where I haven't really been talking at all. And because the computer may not know what things are related to penguins, a very easy way to do that is just to give me random words, perhaps with the modification that maybe it samples English words according to how frequent they are used in English language. So it's going to draw from a multinomial by the frequency of those words. And these are going to be kind of completely irrelevant words so far, but still it seems like many of them could encourage me to think of new things. So for example, game may be something that the AI prompts me. And by itself, it's not related to penguins, but I may start to think game, video games. I wonder what video games contains penguin. Oh, Club Penguin, right? So I could say, okay, penguin is a main character in the video game, Club Penguin, and so on. Okay, so that's a different type of nudge. But of course, there are other things one can do. For example, we could even take the large language model approach where for things like GPT-3, we could say, hey, let's take what the user has already said, and those are colored in this off-color blue. So maybe the user already typed 3 properties: live on ice, cannot fly, eat fish. And we all know the large language model game is you want to condition it, you want to prompt it with some type of, sentences. And the constructed sentence that AI can automatically do is this black paragraph with the blue phrases in it. So it's telling the language model like a property of penguin lives on ice, etc., give it 3 examples, and it just says another property of penguin and stops there and asks the language model to complete the paragraph. And hopefully, if the language model is any good, it's trying to simulate how humans would complete it. And this red thing is literally actually generated by a query to a large language model. As you can see, it's actually quite nice. But the point is, we're trying to take what GPT generated, phrases, meaning has a beak, has feathers, etc., use those as a further nudges to me as a human. So maybe I can, just copy and paste, or maybe I can develop on top of that. All right. So that's kind of the system. It has built in quite a few different types of nudges that it can use. And many of them are based on word manipulation from what I have already entered. So that's fine, I hope. But the point of the talk is actually not this. The point of the talk is AI has access to so many different kinds of nudges. But when it starts with me, when it starts a session with me, it really doesn't know which type of nudges is effective on me. Okay, so the question here is, how can AI figure out which type of nudges to deliver to me so that it's the most useful for me? Now that's actually a more subtle question than it seems. The main problem is this. We all hope AI can give me the most effective nudge type, but it really doesn't know upfront, right? So it has to try, it has to experiment, meaning that it has to give me a certain type of nudge, for example, nearby words in semantic space. It has to try it multiple times in order to establish a reliable estimate of how useful that type of nudge is for me as a particular user. Okay. In fact, it needs to do that for each nudge type. So it has to, try everything and try everything frequently enough to get a good estimate. However, the fundamental issue is the following. If the AI overtries this, then I would suffer as a user. The reason being, some of the nudge types may really be ineffective for me. But in order for the AI to know it's ineffective, it may have to try it 10 times, 20 times. By that time, AI would get a really accurate estimate, like, oh, it really isn't working on Jerry, this type of nudge. But I would have suffered because on those 20 helps, I really wasn't getting effective help. So there is this fundamental trade-off here between what we call exploration from the AI's perspective. It needs to try different nudges and see how good they are, versus exploitation. It really shouldn't try. It really shouldn't explore too much. It should exploit what seems to be good so far. But what seems to be good could be unreliable if you don't try enough. So that's the dilemma. Fortunately, the way I'm describing it, and for those of you who are familiar with the underlying mathematics, you will realize that this problem actually has a solution. There is a notion of optimum exploration versus exploitation, and this is studied under the heading of multi-armed bandit. So the connection is the following. Let's say we have k distinct types of nudges. So nearest word is one type, random English frequency is another type, GPT generation is yet another type. Let's say k is 3. So there are 3 types. In the analogy of multi-armed bandit, they will be k arms. So each nudge type would be an arm. I have k equals 3 arms. And then the idea is whenever the user hit that get hints button, that is as if the user pulls the bandit machine. So what does that mean? The AI has to choose at that moment which one of the 3 arms to use, okay, to deliver a nudge to me. Okay. Now I will let this little t to be the number of times we have requested hint. So the very first time t equals 1, and AI has to choose A1. A1 is the action or arm. Arm at time 1, that's A1. It has to be 1, 2, or 3 to indicate which arm the AI has chosen. Now, let's say A1 actually equals 3. That means it's using GPT generation. It may generate whatever hint it has. It presents that to me. And when I read that hint, what would I do, right? So there are 2 possible outcomes. One is I look at the hint and I actually, I will be inspired to write something, okay? If I do that, we will say, the AI can detect that, of course. We will say, though, the loss to that AI, and I'm going to call it L. Now it has a two subscripts. T means it's the first time we do it. AT means arm3, so it is the loss, the first time arm3 is used. We will define that loss to be 0. So this loss notion is, I was inspired to create something, therefore the AI wins. Or I am still stuck upon seeing AI's hint. I couldn't write any sentences. So in that case, we would define that loss to AI, L, to be 1 at that moment, T, with the chosen arm AT. Okay, so it's a binary loss situation. Now, this loss is equivalent, just flip the sign, it's equivalent to the immediate reward to a bandit. Okay, so this goes back to the bandit model. And the goal of the AI algorithm, or this multi-arm bandit algorithm, is to choose a strategy so that it will suggest A1, A2, A3, A4 up to A capital T to try to minimize its loss, or in other words, try to make me write as many sentences as possible, so to unblock me. So a bit more formally, we can consider the following quantity. If AI were to always choose nudge type I, say I here is 1, that means it always chooses a nearest neighbor type of hints, then it will receive a cumulative loss over this all T rounds of this LTI, right? Now, if you let I to be 2, always use the random English words, it's the summation of LI, LT2, and so on and so forth. So there are K such sums, one each corresponding to a different nudge type always being used. From those, you can look back after the experiment is done. And this is a thought experiment. It's counterfactual because LT1, LT2, LTK, those numbers, we think of them as objectively exists, but for any actual run, you only see one of them. That's the AT's one that you actually, the AI actually suggested. You don't see all other K-1 numbers. But if you assume all those numbers exists beforehand and you look back, then there is the minimum among the K, the smallest cumulative loss among those K arms, K nudge types. And we will just call that A star. You wouldn't know that until the whole experiment is done. And this, as I said, is a hypothetical theoretical construct because, again, the AI wouldn't actually observe all the L's for different I's. Okay, so it seems like it's kind of an impossible quantity. The question here is, can AI design a nudge sequence A1 up to A capital T? And in that case, the actual cumulative loss to AI is the summation over time, but you have this loss at time T with the action AT actually chosen by AI. That quantity, we wanted to approach the loss, the minimum loss possible. That's the cumulative loss with respect to A star. Okay, so we want to do this kind of, in hindsight, minimum cumulative loss objective. Now, this objective is actually called regret. And it turns out there is an algorithm that the AI can actually run. And I'm not going to go into too much detail, but the basic idea is AI would maintain a set of K weights. Initially, these K weights, one for each arm, is all ones. And in each iteration, at step 3, AI is simply going to normalize those weights across the K arms to form a distribution. It's a multinomial distribution. And it's simply going to choose the nudge type AT at that round by drawing from that multinomial once. So it's going to choose an action from 1 to K. At that moment, it will receive the loss because I either wrote something or didn't write something. So the key there is this loss will be used to update the weight of that arm, that particular nudge type. If I was successful, the loss is 0, the weight will not be changed. However, if the loss is 1, I was not able to write anything, the loss will be reduced by a very specific amount. Okay, so that's the main idea. Because the weight will be lost in the next round, the probability of choosing this arm again will be smaller. Okay, and the interesting thing is, with this algorithm, one can say something very nice about what the sequence of. Number one, the AI has a way to choose this sequence of 80s. And number two, one can say something about the cumulative loss under this sequence of 80s. It is close to the minimum cumulative loss. There is this additional term that looks like a bunch of variables in it. The key quantity is the square root of t, the number of rounds, but it's under square root. So that additional term will be small compared to the number of rounds t. Basically, if you divide by t on both sides, that term approaches 0 as t gets large. So that's why this type of algorithm has the guarantee which is known as no regret algorithm. And in the long term, it will figure out what's the best arm for me, but also not making me suffer too much along the way. So that's in our system. And this human experiment is ongoing, so I don't have actual human results to show you yet, but we anticipate it is going to have an effect using this type of arm selection or notch type selection compared to something more naive, like if you just randomly select one. I'm almost done, so let me actually say a couple of things about what this is and is not, or limitations. So one thing that it is not really able to do is to model the internal state of the humans. This is in response to the kind of intuition that if I was nudged many times by nearby queries, even though nearby words were effective in the beginning, maybe after a while I cannot use it anymore. I would prefer a different type of nudge, right? So what that basically says is, I, as this creative writer, I actually have internal states, and this my state will be changed by the things I wrote and the hints I receive. And that is ignored by a bandit style model. So that's not there. So all we did with multi-bandit is just an approximation. However, there are some ways to build in states in this in modeling me. And one direction that's possible is to use reinforcement learning techniques instead of bandits. Really, that's just like introducing states. The second limitation, and that's a fundamental one, is this approach really just says, if somebody designs a bunch of k different nudge types, it can automatically balance them based on empirical effectiveness. It really doesn't go into understanding why any of the arm or nudge types work or does not work. Okay, so that's a huge limitation because that doesn't really give us cognitive insight as to why something is working. And the third limitation, which is quite related to the second one, is the AI is also quite limited in that it doesn't know how to suggest or create new nudge types based on the k nudge types it was given. So because it doesn't understand how any of the nudges work. So this again is a fundamental limitation, although I anticipate to some limited amount, one can create new nudge types if you, for example, allow the AI to have a space of compositional nudge types that it can put bits and pieces together. In that case, there is some hope for AI to, again, automatically figure out what's an optimal composition of nudge types. And this is related to multi-embedded in the case of when you have a larger action space, and those actions has a compositional structure in it. So yeah, that's about it. Thank you very much. And I look forward to discussions and questions.
Great. Thank you very much. It seems like there's a lot of activity in the chat and people have many questions. So I would let anyone who has been raising many issues in the chat, just raise them now. We have a time for maybe a couple of questions.
Hi, Jerry.
Hi.
How are you? I'm just curious regarding the human experiments. I would like to hear more about what you are planning to do, and in particular, what do you expect to learn from those, and how do they relate to the system or model that you have presented?
Certainly. So the real reason is we just had a summer break, and our student subjects who are not here. That's all, right? But the actual experiment is, as you would expect, we plan to have the system with, when people click hint, really they're running this multi-embedded. And there are several comparisons. One is you can just say another condition with no hint. People can just type, but there's no hint button, right? So we anticipate, given the same amount of time, people in the no hint condition will produce less number of properties. A more advanced baseline is when you present, you still allow people to get hints, but those hints, underlying that there are still the same K types of nudges, but the AI is not choosing them in this, multi-embedded way. Maybe it's choosing them simply by either uniform distribution or by, what seems to be the most effective so far. So the leader type, both type we know in theory should not be as good as EXP3 type of banded algorithm. They will have larger regret. That's what I was saying. So we anticipate to see that in human experiments.
Right. Thank you. Just a quick following on that. In terms of exploration, exploitation, what would you expect to learn from the human experiment?
Right. So here, it's very limited. We're not actually anticipating much, in the sense that the exploration is purely done by the AI over the K arms, like the choice of the K arms. So it's not something like super insightful, I would say, like, because it's it really relates to the limitation of we don't know how to tell AI why each arm works. Mm-hmm. So it will not see that. The AI in our exploration is just going to try it and then measure the immediate reward, and it will accumulate, like the statistics of over time, right? But then that's to the extent it. So I think it's rather limited, and I think that really is the research question going long term. Yeah, great question.
Okay, thank you.
Jerry, very nice work. I like this idea of expanding human creativity, and I wasn't quite clear how you score the humans that work with this AI. Mm-hmm. So if the goal is to get humans to be better, more creative, mm-hmm. How do you know if they're just not copying what the AI is giving them? So if the AI says the nudge is eggs, and the human says, "Oh, lays eggs," of course. Is that creative? Should the human get credit for that? Should the AI get credit for, for producing a human response? And how do you? And a follow-up question from Paul was, how do you do any scoring? The score whether something is creative or just copying? That seems a very hard problem.
That indeed. We are absolutely ignoring that for now. We're just saying, we see how many sentences basically people can produce. We're not going to check the quality. I mean, although you could think like you could have other humans annotate the results, right? So that would be the standard thing, just to give it like a creativity judgment score and so on. For now, we're not doing that. And I don't see an automatic method to do that. It really is like challenging. But going back to your question, right? So if the AI is going to suggest, like the GPT-3 example, AI is actually going to suggest some really good features for penguins, right? And the human subject could just, copy them. And it's not creativity at all, right? In that case. So the real use case that we hope to for this is for people to come up with novel properties, as many novel properties that are not commonly included in the standard word norming database. So it's like you want to add many more columns of interesting things that people don't think of. So that's one use case. But a real world application separate from word norming is the situation when we envision when people, companies need to create a new text classification, right, on novel tasks that didn't exist before. Maybe by regulation, by law, etc. They really need to create that tomorrow. And they don't have the proper training data for that new category structure at all. This is where the experts in the domain could try to sit down and essentially create a mini seed training corpus. And we're envisioning this can help rather than they just sit there and think by themselves. If we just hang them with different things, they are motivated to create high quality corpus, but they are just being blocked. So I'm not answering your question. I'm just saying like there is a possibility that this might be useful, but we don't see a way right now to automatically judge the creativity of sentences people produced.
Thanks.
Maybe a related, question / suggestion. So my understanding was essentially this could be useful for creative writers as well. For example, if you write a short story or a novel, right, and you're stuck. And so in a way, maybe one interpretation is that we're not even that interested in answers being produced by a human, but rather by this system. As long as something is being produced, we are satisfied with how the system works, right? And the mere fact that the human decided to use the hint and to make another continuation already means that this human that was working with the machine was actually satisfied. And so maybe a simple way is to ask the human who is using the machine to rate the suggestions right away, as opposed to using other humans who would later rate the results, just because from ultimately it's the human who is using the machine who is the user. So maybe their opinion is actually important.
Yeah, thanks for the suggestion. Let me comment on that. I mean, what you said is absolutely valid from a kind of a operational perspective, right? You could say the human is just look at, for example, GPT-3 generations and just pick and choose or rate them and say, okay, I like this, I don't like that. I think that would be valuable as a short-term thing. The longer-term goal still might be like we want to get the human into the pipeline, because if the topic is something that's truly new, like for example, something that just we suddenly discovered a new element, and the whole internet would not have that discussion, and GPT would not be able to say something sensible, right? But a chemist could be. So in that case, there is still value in, machine just produce something that's not directly usable, but can help that chemist say more about it. So we still hope to get to that stage. But yeah, thanks for the suggestion.
Great. Thanks everyone for excellent questions, and thanks Jerry for thought-provoking talk and the answers to the questions. I think now it's time to switch to Paul's talk, and we will have more open discussion in the end of both talks, and people will have a chance to raise other issues that they have been discussing in the chat already.
Okay. Okay, this is going to be a very different talk than Jerry's. It's going to be, I think, much less pragmatic and technological and much more abstract and theoretical. Hopefully that'll be fun. I wasn't totally sure what to talk about for this, but I thought I would talk about this project, or sort of set of connected projects that I think relate to the idea of augmented intelligence in a kind of slightly oblique way. So let me start just by noting, right, something that we all know: humans are groupish. We do things intelligently and adaptively in groups, and groups do things that are collectively intelligent and adaptive. And people in groups communicate and they share information in a structured manner. We know a lot about this, right? The way groups are organized has a strong influence on how individuals behave and solve problems collectively. This is what a lot of sort of modern network theory and social network theory is about. And I want to highlight something, which is that, you know, humans assort in non-random ways. This is really important. So in terms of political affiliation, this is on the left is the US in 1976, and each little square or, you know, outline is a county. And the white counties are those that where the presidential vote in that election that year had a margin of less than 20 percentage points. So the right is 30 years later. You can see there are a lot fewer competitive counties. What's happened is that, in addition to a little bit of gerrymandering, is that people have tended to move where they live. They can live near people who are like them. And this is not just in physical locations, it's online locations. There's a lot of evidence that the people you connect with online, so here's Facebook, but the same is true of a lot of other networks. People tend to be friends with people who have the same political affiliation. People assort on things that are not just political. This is a map of New York City, which is near where I grew up, where every dot represents 120 people in the census that belong to one of the ethnic groups that the census takes track of, right? So white here is represented in green, orange is Hispanic, red is Asian. And you can see that people cluster in ethnic neighborhoods. It's a very segregated city, even though it's also very mixed and, you know, a melting pot. So people assort with people who are similar to them. And one way we figure out who is similar to us is by marking ourselves. Right, so people often mark themselves to signify group membership. This is, you know, related to what we call identity. So here on the top, these are East German punks in the 1980s. And on the bottom, we have MBA students at Chapman University. Now, ethnically, there's not a huge variation in these groups, but identity-wise, you can expect pretty different things if you approached either group just by looking at the way they're presenting themselves. In the US, a major split currently involves political ideology, and people mark themselves accordingly, right? So on the top, these people have actually tattooed themselves with images of Bernie Sanders, where on the bottom, people are very clearly stating their support for fascism. So what are they doing, right? They're identity signaling. So I'm going to use the word identity signal a bunch. By this, I mean any component of communication transmission, so language, displays, fashion, other behaviors, anything that informs receivers or listeners or viewers of a signaler's membership in some categorizable subset of individuals. Like, this is a huge part of what it means to be human. Humans are basically the only vertebrates that live in these large anonymous societies where we can cooperate regularly with people we've never met, the individuals we've never met and seen before, because we can use signals to say, this is the kind of person I likely am, and this is what you can expect when you see me. So this combination of how we identify individually and how we perceive other people's identity is going to shape how we perceive them and how we perceive the information that they give us and how we make decisions about what to do with that information and with those people. So I'll give you a quick example. This is a study that I was involved in recently, led by Maya Powell, who's a grad student in the applied math department at Merced, and her advisor, Arnold Kim, where we were interested in perceptions of the hashtags Black Lives Matter and then the sort of counter hashtag All Lives Matter. This is on Twitter. So all this data was we collected a bunch of data, collected a bunch of tweets, all done in 2020 after a bunch of sort of racially charged events in the US, in particular, the murder of George Floyd in Minneapolis. And what we did was we asked a bunch of people, we showed them tweets that had been marked with these hashtags. And for some of those, we just artificially removed the hashtag. And you can see that on the x-axis here is the self-identified political orientation, which was derived from a number of questions. And there's this strong relationship where if you are shown something that says hashtag Black Lives Matter, you're much more likely to find it offensive or racist if your affiliation is on the political right and not on the political left. Moreover, especially for ratings of racism, taking away the hashtag and sort of the same content of the tweet is there, but it hasn't been marked in this way. And that identity marker sort of does extra work in telling people what they can expect. And when we ask the same questions for All Lives Matter, you see the exact opposite trend, right? All Lives Matter is found much more offensive if you are on the political left, and especially if it's marked with a hashtag. And this is just to point out that identity shapes how we perceive information and the source of that information. But I also think that, sort of parochial social learning preferentially from individuals who are like us can be adaptive. So we rely, what I'm going to say here is really drawn ultimately from this book and related work by Boyd and Richardson. We rely on social learning. Social learning is especially important when we're uncertain and there's variable environments. And so we don't know what to do. We should learn from others who may have privileged information. But the effectiveness of social learning is going to be diminished if what works for someone else is not likely to work for me. And so I shouldn't learn from them if they're doing something that's not, going to work for me. If they're in a different environment, they have different affordances. And so identity can serve as an adaptive cue for identifying targets of social learning. If someone is like me, then they are likely to have similar, they're in a similar milieu as me. There's a lot more research on how identity aids cooperative assortment, right? So we need to cooperate, and that involves a lot of coordination. So coordinating on norms and expectations and goals. And so we want to find people who share those norms and goals and expectations. And the issue is we don't always know who is going to be like us just by looking at someone's face, right? So imagine a world where there's two norms. There's the green norm and the purple norm. And so purple people want to interact with purple people and green people want to interact with green people. But you can't tell who's purple and who's green. So traditionally, the solution that's been proposed is some kind of overt marker, tags, social markers. These are things like how people dress, how people talk, behavioral cues, slang, shibboleths. So a lot of work has been done on these kinds of signals, which are really important for between group assortment. And this basically solves the problem. If you interact with someone, if you just only interact with the green hats, if you're a green hat and only interact with the purple hats, if you're a purple hat, everyone gets a coordination bonus and everyone is happy. This is, there's more nuance to this that I want to get into, but I'm gonna take a really quick detour, which is one that assortment isn't always good. Since the pandemic started, I have just been unable to stop thinking about this paper from 2008 that I read a while back by Marcel Salate and Sebastian Bonhoeffer on the effect of opinion clustering. So what they did was they did a simple network model where agents vary in the likelihood of adopting vaccines to an outbreak of a disease. Can you imagine? And then they looked at the probability that if there's an outbreak, will that spread and become an epidemic? And this is the normal approach in standard epidemiology and even network epidemiology, is to assume that vaccines are distributed at random. And then you can calculate thresholds for herd immunity and say, okay, as long as we vaccinate some percentage of the population, if it's this effective, then we'll avoid an epidemic. The problem is, though, that the vaccines don't exist at random. People who get vaccinated tend to be connected with other people who are vaccinated. And similarly, people who are unvaccinated tend to be connected to other people who are unvaccinated. And so you can get these big clusters of lots of people who are unvaccinated, which provides a lot more opportunity than you would expect under random mixing for the thing to spread. And so for the same level of vaccination coverage, when you have clustering, you have much higher probabilities of an outbreak. I had a paper recently with Jamie Holland-Jones at Stanford, and we did a contagion model of sort of two contagions, trying to look at what happens when there's identity is related to the adoption of a behavior, and that behavior is related to the prevention of a disease. So things like social distancing and vaccination and wearing face masks, et cetera. Right? And you can, I'm not going to spend a lot of time on this because I want to get to something else, but the take home here is, so the proportion of the population that's infected is on the right side of the y-axis. And when you have no homophily, so groups interact at random, and you have no aversion to whatever the outgroup is doing, then everyone basically adopts the behavior that is preventative, and you have fairly low peak infection rates of about 5%. But if you have outgroup aversion, when one group adopts the thing and the other one doesn't want to because they're averse to what the other group is doing, you have much, much higher peak infection rates. And when you add homophily to that, you get a big difference where, even though in this model, the disease first breaks out in one group, in group 1, group 2 actually experiences a much higher infection rate because they haven't adopted the preventive behavior. And unfortunately, we wrote this paper in the first spring of the pandemic in 2020. And unfortunately, we're seeing this play out, right? So this is in the US, where there's this big correlation between the likelihood of doing things like wearing face masks or getting vaccinated and political affiliation, because it's identity related. And so we saw initially most of the deaths were in counties that were heavily Democratic because they were in urban areas where there's lots of mixing. But eventually, the rates have gotten much higher in the rural areas and the places that tend to be Republican leaning, because they're not adopting the preventative measures at as high rates. Okay, this is the meat of it, right? Which is that I want to talk about, which is that people signal identity in lots of different ways, right? You can be very overt, and this is who I am, but you can also be a lot more obscure and subtle about how you're signaling. So when we have between group assortment, this is great because it allows us to say, I'm going to definitely interact with the purple people and I'm going to totally avoid the green people. And that way I never have to talk to a green person. And maybe that's okay, because you never actually want to talk to green people. But first of all, most of us live in diverse societies where we have to interact with lots of people all the time, even if we don't want to. And even among the people you do want to, there's still variation, right? So when you do this and you have these overt markers, you burn bridges with the outgroup. Within a particular group, everyone is not the same. It's not a monolith. There's variation. And you can't just avoid interacting with people just because they're a little bit different than you, because we live in a cooperative society. So when we're talking about separating between groups, we have ethnic markers, and it's fine because you can assort on norms easily, but it eliminates cooperation between groups. Within groups, we would like to be able to assort on norms when possible, but also be able to cooperate with people who we might not, choose given all possible options, but we're stuck with them. Verbally, this idea was laid out really clearly by Glenn Loury, who's an economist. In 1994, he it's a nice paper on self-censorship, and he writes, if the significance of some words as signals of belief is known only to insiders, their use in public allows the speaker to convey a reassuring message to some listener. I share your values without alarming other people. So an example of this I like is kind of terrible, especially recently. In the 2004 presidential debate, George W. Bush kept referring to the Dred Scott decision, which, if you don't know, is a 1857 US Supreme Court decision that was terrible, right? Where Dred Scott, a Black man originally from the South who was a slave, was brought into a free territory, I think Illinois, and he sued for his freedom. And it went all the way to the Supreme Court, and the Supreme Court decided he couldn't, they decided against him, saying because he was Black in the pre-Civil War US, he did not qualify for the rights of citizenship and therefore was not eligible to sue for his freedom. It was a terrible decision, and George W. Bush said it was a terrible decision correctly, right? And said, this was a terrible decision. We want to make sure we never have something like this happen again. Why would he do this, right? Basically, everyone who's not like a terrible person agrees, at least in public, that this was a terrible decision. So it's not controversial. However, among groups of evangelical right-wing Christians in the US, Dred Scott was often analogized to being another decision by the Supreme Court that they viewed as similarly misguided and terrible, which was Roe versus Wade, a decision in the 1960s, which guaranteed until very recently the right to legal abortion in the United States. And so instead of coming out and saying, I hate abortion, what George W. Bush is saying is, hey, people who know this connection, I see you and I'm signaling to you my commitment to ending legal abortion without alarming, let's say, moderate voters who don't want to get into that. So this is a pretty extreme example. It's kind of political dog whistling, but there's lots of more quotidian day-to-day examples of this. Like a lot of jokes and humor is not funny to most people because it references information that you need to be an insider to get. People who are interested in fashion like to wear things that aren't overtly marked with the brand name, but have cues that only people who are kind of insiders get. So political dog whistles I've mentioned, and other kinds of persecuted minorities. So let's say members of the LGBTQ communities or political dissidents in some places have incentives to find and signal to other people who are similar to them so that they can meet up, but have costs if they're outed to the general public. And so they have incentives to be able to signal in a more subtle way. So this leads us to a theory of covert signaling. So this is the transmission of identity information that's going to be generally accurately received by its intended audience, people who are similar, but obscured when perceived by others. This was developed with Tom Flamson and Richard McElreath. This contrasts with overt signaling, in which honest signals are widely broadcast. And we can use modeling to ask, what conditions is selection, so I'm thinking cultural selection, going to favor the evolution or the maintenance of covert signaling strategies? So we build a model that I'll go through pretty quickly. Individuals have strategies for signaling. They signal something about themselves using their strategy. Those signals are received by others sometimes. Then people use the information they've received to assort for some cooperative task, and you get payoffs from those tasks, which lead to differential fitness, and fitter strategies, higher payoff strategies, are more likely to get copied. So you can signal either overtly or covertly. Overt signals are received by more people in general because they're overt, including members of an outgroup or who are dissimilar. It doesn't have to be distinct groups either. It can just be some sort of threshold for similarity. Covert signals are generally noisier, but they're obscured to the outgroup. Then you have attitude formation. It turns out it matters if you have assumed sort of generous or churlish receivers. So some people might remain neutral toward people if they don't know anything about them. Some people might assume that everyone is terrible unless they confirm that they're not. We then use this to get cooperative assortment. So in some populations or communities, it may be possible to completely use the information that you know about someone to say, I am only going to interact with people I like and never interact with people I don't like. In other cases, like most we can imagine, you sometimes have to interact with people you didn't pick. So the degree of homophily, if homophily here is 0, then all matches are at random. If it's 1, it's everything. You can perfectly exclude people you don't like, and in the middle, it's somewhere in the middle. And then we assume that if you can match up with someone who's similar to you, that's better. And if someone is dissimilar to you and they know it, that's worse than if they don't know it. So you have to interact with someone who's similar. That's better than interacting with someone who's not similar to you. But if you're aware of your differences, we assume that this impedes cooperation, or could, right? We impose a cost, which could be zero, right? And then we have selection, where individuals with higher payoffs reproduce their strategies. So we did this initially with a mathematical model using replicator dynamics. I'm not going to present that. I'm going to present results from an agent-based model done with my former grad student, Matt Turner, where individuals here have strategies, and traits are, there's not a single in-group, out-group identity, but rather we assume that everyone has lots of traits, K of them, and each one is a binary trait, so it could be on or off. And if you share some threshold number of your traits with someone, you're deemed similar and you get the bonus, otherwise you don't. And that's how the model works. And quickly, right? So I'm going to highlight the major results of this. So covert signaling evolves when homophily is low and the cost of being signaled is high. How am I doing on time, Marina?
You have maybe 5 to 7 minutes.
Perfect. So covert signaling evolves when homophily is low and the cost of being disliked is high, right? So if the cost of signaling, if homophily is high and I can always interact with the people I know are similar to me and avoid people who are dissimilar to me, I should signal as overtly as I can, because I can always avoid people who are different. Similarly, if there's no cost to occasionally interacting with people who are different from me, I should still signal overtly. But if there is some cost and I occasionally have to interact with people who might be different, I'm more likely to be incentivized to signal more covertly. And it's important that covert signaling also co-evolves with generous receiving. This is really interesting. It's no use to signal covertly if everyone is going to hate you no matter what you do, unless you can prove to them that you're like them. And then we can talk about the evolution of deception, which we've ignored here. Similarly, covert signaling is going to be favored in diverse populations. So we can use the similarity threshold, S, as a measure of diversity, because the higher the threshold, that means the more people, the more likely some random stranger is going to be different from you, because you have to share more and more things in common before you're deemed to be similar. The things that are different are deemed to really matter. Whereas when S is low, as long as you have a couple things in common with someone, that's good enough, and you can cooperate with anyone. And the more a random stranger is likely to be different from you, the more likely it is that covert signaling is going to evolve. And this got us thinking about the fact that similarity is not the same for everyone. Some people, if let's say you're in a majority, most people might be similar to you, whereas in the same society, members of minority groups, most people are going to be different from them. So you have different incentives. So we were able to do this by building this model where a majority and a minority were established, where the first, slightly less than half of their traits were fixed. And therefore, members of the majority were likely to be similar to other members of the majority, and same for members of the minority, not guaranteed. And then we just looked at covert signaling among these two different groups. And what we find is that, covert signaling is a lot more prevalent among members of the minority. They're much more incentivized to evolve covert signaling than the majority group. So the takeaway from this is that covert signals are going to be more common and more favored when the cost of being disliked is large, and when people are going to be more likely to have to interact with people who are dissimilar or in the outgroup. And this condition is met when A, people have to interact more with partners they didn't choose. 2, B, let's be consistent, people live in more diverse populations, and C, individuals belong to a minority group. So this is a model, and it was important to test this empirically. Covert signaling is actually really hard, it turns out, to test empirically, because you're, by definition, dealing with signals that only members of an in-group can identify. But this was in collaboration with Mirta and Tamara Vanderdoes and Zach Donovan. This came out this year in PNAS. We did this looking at to see if people strategically alter their signaling behavior in a way consistent with these models. So we came up with this pretty elaborate way of having people, we used political identity, and we got people's tweets, and then we had people who were from either the right or left, on moderate or radical, rate the tweets to decide if they could determine if they were political in nature or not, and if they liked them or disliked them. And we used the differences between these groups to decide if something was covert, meaning only one group identified it and either hated it or loved it, and the other group didn't care, whereas overt signals where everyone had an opinion, essentially. On Twitter, we find that people with more heterogeneous follower networks use more covert signaling. So if the people who follow you are more spread out across the political spectrum, your tweets are associated with more covert, are more likely to be deemed covert. That effect is pretty weak, partly because on Twitter, we have this homophily problem where people are generally in networks where people have similar views. In person, the effect is much stronger, where we gave people a bunch of tweets from their same political side, but some of them were covert, some of them were overt. We didn't tell them which was which, they had to figure it out. And we said, here's an audience, it's 10 people, and X of them are on the same political side as you, and the others are not. And what we find is, one, if you're in a minority and your audience is mostly members of an outgroup, you're just going to be much more choosy about what you signal in general. Those people just picked way fewer tweets. And among the tweets that they did pick, they were much more likely to be the ones we had rated as covert. The effect of cost that we got was not statistically significant, although it was in the right direction. My guess is that the difference between our high and low cost conditions was about 20 cents. And so it just wasn't enough to register. So it's something to look at in the future. Okay, to recap. Identity signaling and parochial social learning are probably adaptive strategies in many cases. There's good reasons why we do these things. And I think understanding when they're adaptive and why they're adaptive is really important to understand when those adaptations can fail. And they can backfire in cases where collective goals and benefits transcend identity boundaries, like, let's say, in a pandemic. Identity can constrain information flow and behavior adoption, and this has downstream versions that affect population dynamics. And finally, identity signaling involves multiple strategies. It's not just in-group, out-group, us and them. It's people have multiple identities and they signal their identities in multiple different ways depending on context. And this is sort of just the beginning. This is a big thing that I'm interested in, and my collaborators are interested in, and I feel like we're just getting started with this. So I know that was a lot. So thank you for your attention. And that's all I have.
Great. Thank you so much, Paul. And I would want to invite everyone to raise their questions that they have. I see at least one question in the chat.
Yeah, Paul, thank you very much for the talk. I'm just wondering, like, I want to be on the devil's side and to challenge the basic assumption with which we all seem to share, that people seek to interact with those similar to them. So are there any social contexts where they would do the opposite, like where they would actually seek to interact with someone who are very dissimilar and avoid similarity? Thank you.
It's a great question. So yeah, is actually some of my first work on identity was about drives for distinctiveness and differentiation. So yes, that is definitely a thing. And people, I don't know if this is exactly what you're getting into, but like there are certainly motivations to interact with people who are dissimilar. There are many problems to be solved that benefit from complementarity and division of labor, and that can benefit from differentiation of, let's say, personality types or other kinds of maybe identity related things. There are a lot of benefits to certain kinds of diversity in collective problem solving that we know about. I still think, though, that all of those the research areas have the background assumption that there is some amount of shared goal. right? And the assumption of cooperation, right? You might want to interact with people who are different from you because you have a shared goal and you feel like differentiation can help you solve that goal. But if your goal is completely opposed, it seems to me very rare that people, really want to interact with people who have directly opposing goals. Maybe I'm missing something.
Yeah, just one example that I came up with is that at scientific conferences, people tend to seek to interaction with those who quite dissimilar, but it looks like there should be if there is very dissimilar, then people cannot get into the conversation. So they just seek to sum a bit of the similarity, and it's quite funny that, for example, CoxSci conference, it always strive for this diversity and all this kind of stuff, but it end up every year and end up quite how say collecting typically those people who've been there previous year and those who visit other conferences I don't know, which are typically held in Europe. They end up interacting with those who are actually similar to them, even though they seek to some diversity. Sorry, yeah, just one more thing. You use the concept of social dynamics and social interaction, which are, for me, are quite vague, because judgments, when you into collective judgment task, it might be completely different story from doing cooperative work or from individual judgment tasks. So, for example, if I seek for advice about my health, I would probably look for someone who is dissimilar to me, but who has better, education in medicine, for example. So it looks like it might be the function of the task. So if the task is to work together or to just share, some emotional states, then I would seek for someone similar to me. But if the task is to, for example, make an accurate judgment, then maybe I would benefit from interaction from someone similar.
I think my answer is the same as before. I totally agree with you. You're absolutely right that we often seek out people who have different knowledge and different experience or different proclivities than we do, because that benefits us, right? I mean, you made me think also it's a very famous result of the strength of weak ties in, let's say, job search and other things. But I still think, you go to see the doctor because you have they're different from you. They have different knowledge, but you both have the shared goal of making you better, right? Hopefully. And that is a sort of, and people still often want to see doctors and professionals who have other kind of identity similarities to them, let's say similar ethnicity groups or class background, or they're from similar areas, because people get excited when they move to a new area and they meet someone who's from the same place they are, right? Because you have the same references and you can coordinate on certain things more easily.
Thank you.
Maybe to add a little bit to Roman's question. So when we're speaking about, I could think about two cases where seeking purposefully a person with opposing ideology makes a lot of sense, right? One would be conversion, and another would be trolling, right? And so, and I think that both of those happen. So do you think, what do you think? Do you have any predictions about the dynamics of those? Because essentially, my intuition would be, as groups become more and more isolated, the number of people who do realize that the groups are actually very isolated, and let's say if somebody wants to do social activism of some sort, if they actually want to propagate their idea, they have to reach across the gap, right? Otherwise, it's just useless.
That's a really great point that you bring up. I think conversion is interesting, in part because it is about bringing more people over to your group. It's trying to sort of increase the strength of your own group identity by seeking people who you feel could flip from another group identity to your group identity, and that it's not you're right that this is not a cooperative assortment problem, but it is there's like a meta problem that is ultimately the goal. but you're right, it involves solving different problems. Trolling is a fascinating example because you're, explicitly trying to kind of hurt or annoy people of an opposed identity group. But this is still, potentially, it still could be viewed as a in-group cooperative task. You're, benefiting your in-group, at least so you think, by attacking or hurting the out-group. I don't think all of these things, certainly they're not explained by the models I presented, because the models I presented are about, like, they're about what they're about, and they kind of, I'm sort of saying, okay, well, let's focus on the kinds of tasks that are important, that are, benefited by assortment with similar individuals. And, we say in the papers, like, we're explicitly ignoring differentiation, but I think that an identity is really important, not just to know who to cooperate with, because you're always looking to cooperate, but also because you're trying to figure out who to avoid, who to attack, right? And or sometimes, in some contexts, is what kinds of interactions you can have. It's not sort of all or none cooperation, right? It's like, okay, I can have an economic transaction with this person, but they're not likely to become my friend. I'm not going to invite them to dinner, right?
Great.
Yeah.
Thanks. Sorry,
I had
go ahead.
just last short question. So I was wondering about kind of semi-covert signals. So you could maybe call them euphemisms, in the sense that some signals may be easy to decipher, but essentially you recode the signal in such a way that it's less socially judged by the other side.
Yeah.
Or like formally you cannot be judged because of it, but it essentially explains the same opinion. So do you have this kind of two-axis system for those signals, where one system is, or like one axis would be how easy it is to decode, and another axis would be how reprehensible it is for the other side, or something like that?
It's a good question. There's this part of what you're talking about is sometimes called indirect speech in some of the psychological literature, right? This is the, like, the classic example is, like, do you want to come up for a cup of coffee if you're on a date, right? You can, there's plausible deniability. Like, you both know what you mean, but you can pretend kind of that it's about something else, because, you could argue that you were just inviting someone up for coffee. Yeah, so we didn't include that in any of the models, but we did notice that in our experiment, that it wasn't all or none. The model, that's a modeling simplification, but actually members of the outgroups in our experiments could identify the signals from the other group that were covert, just at a lower rate. And so, finding out, like, how encrypted does something need to be depending on the context, that's probably another axis that we hadn't really considered in our modeling, but we talked about in the paper, and it's something that's given us some food for thought for future work.
Great.
I have a kind of a broad methodological question for both Jerry and Paul. I'm slightly frightened what the answer is going to be. The general question is, has traditional psychology been of any use to you in the work that you've described to us? So, for example, with Jerry, has research on, the psychology of memory or creativity brought any interesting suggestions about what kinds of nudges would be useful, or provided evidence that there's very marked variability between individuals in what kinds of nudges they need? And with Paul, I suppose it would be the social come political psychology of prejudice. Did that suggest any hypotheses about the conditions in which you would find a lot of covert signal and so on? As I say, I asked this question in fear that the answer is going to be, no, looked and it was no use.
I will go first. I think I can say I don't know yet, in the sense that we have been approaching this in a very empirical way. And we fully anticipate, really, what you suggested is going to be extremely useful. We just don't we're not at that point yet, in the sense that our notch types are currently designed, you can even say, by graduate students from completing tuition and so on. So, but I do anticipate the next step really is to think that essentially my second point in future work, right? This AI computational approach doesn't really know anything about notch type. It doesn't know the inner works, right? It just knows the empirical success rate. That's kind of what it is. And so I think that's an orthogonal direction and absolutely important. So I anticipate that to be valuable.
Great, thank you. That's reassuring.
I mean, you know, the answer is yes and no for my work, right? I mean, I did my PhD is in psychology, and I was influenced a lot by psychological research. And you know, like I said, I just mentioned the literature on indirect speech, which mostly comes from psychology. There was a lot of literature on ambiguity and strategic ambiguity in particular, which comes from communication and political psychology. A lot of the work on identity has been really thought-provoking and has given me, let's say, and my collaborators creative nudges to think about things in different ways and ask different questions. You know, I think of this work as really integrative because I'm really interested in instrumental functions of behaviors and cognitive strategies. So, you know, if we think about things like identity, I think it's important to think about, well, what does identity get you? What is the purpose of identity for the person? And what is, if people express identity internally and externally in different ways, why do they do that from a strategic or from, even if they're not consciously aware of it, right? And I think they're not often consciously aware of it, but what does it get you? And I think psychology has historically had a really hard time with asking that kind of question. A lot of it has been very phenomenological. Like, what does it feel like to have an identity? How do I express myself in a way that makes me happy or dissatisfied, right? And it's very much about the internal experience and very little about what the population level consequences are of particular behaviors or strategies.
Yeah. And of course, I think that perspective is extremely valuable. But if I could just follow up with one specific thing, which is, say the results of your cultural selection-based models turned up results inconsistent with what research in the psychology of prejudice showed or whatever. It implied that covert signaling is going to be common in a different set of conditions than is documented in that literature. What would you conclude from that, you know, if there were that conflict?
Yeah, this is a great question. I think, you know, it depends, right? One question is the psychological literature sound, right? Is it, which these days is a question we have to ask. But let's assume that it is, and let's assume that it's robust. And, you know, one thing I would ask is, what are the assumptions of the model, and are those assumptions being met, right, in the conditions under which the psychological studies are being done? Are those studies being done in a way that is, let's say, universal, or is probably not, right? Is there some cultural variation in the costs and benefits or the ability to, you know, assort or signal in particular ways? I would ask questions like that. You know, I think right, I mean, like, it's a cliche, all models are wrong, but they're wrong in non-random ways, right? So every model is going to break at some point, and if you push it hard enough, and what you learn from that is, okay, well, what assumptions is the model making that are not met by a particular, this is getting, sort of just general philosophy, but what are the assumptions that the model is making that are not met in some particular empirical setting? And then my question would be, is there a way to adapt the model or change the model in a way that better meets so that its assumptions more accurately represent the scenario? And then do we get you know, what's happening, right? Because then we have a candidate explanation.
Okay, good. So in a way, you would see the data, provided it's methodologically sound and the effects are replicable, as sovereign, but the modeling is giving you some information. You said about function, but arguably about origins as well. The origins of, you know, the empirical facts in cultural selection.
Yeah, I mean, it's, yeah, I would ultimately, right, if the data are good, then the model has to, you know, then the model can't say that the data are bad. The model might say the data aren't the way they are because of the reasons we thought they were, right? And there may be different reasons why these data happen to look like they do. And it's, I think of it as like a long-term iterative process where it's back and forth between data and model.
Great, thank you.
Excellent. So I would want to invite anyone else with their thoughts from the chat or from their minds to raise their questions. But in the meantime, I would ask the question that I'm interested in, that I think might also connect to talks. So I'm interested in co-adaptation, and in particular for Jerry's case, it would be the co-adaptation of the human and machine working together, and machine nudging the human to do a certain thing, but human can also adapt their sensitivity to these nudges as they're being nudged. So I wonder how, whether you consider this possibility and how this would affect the optimal bandit solutions that you discussed that do not presume this sort of adaptivity. And for Paul, I guess the co-adaptation could play out in the fact that potentially overt and covert signaling might be potentially useful in the context of more or less covert and overt signaling. So if there's a possibility that everyone is signaling in a covert way, maybe it might be more adaptive to signal in an overt way, depending on the situation. And again, I wonder if this is a possibility you consider and whether this would play out in your model or it's already ingrained in your model.
Okay, maybe I can start.
Sure.
My real brief response is, Marina, this is a great point, and in fact, this is the major research in my lab. But you know, minus the human psychology part. So what is funny about it is my group actually is very interested in multi-agent systems, and what you just described could be potentially modeled as, you know, the co-adaptation really is about this human being a complex dynamical system, but it receives nudge. But as long as we can either describe the underlying dynamics or try to estimate it in a black box way, then you could say what's the effect of any external nudge to the internal state of this human, and conversely, how that human would perform its future actions based on its changed dynamics or internal state. So, so the way we have been approaching this problem is we're now into a little bit of multi-agent reinforcement learning, a little bit of game theory in among those two, to try to find some mathematical kind of guarantees or algorithms in order to study the kind of optimal nudge or optimum resistance, if you may, type of question from like interpret it as your human counterpart there. But yes, I think there is this potential direction where you really could just model both entities as dynamical systems so that their actions affect each other in some ways. You can certainly bring in strategic considerations, game theoretical kind of considerations as well. So I think that's a potential direction.
Wow, yeah. I just want to say there's so much to think about with your work, Jerry, that I just keep keep thinking about it. It's really cool. Yeah, I think you're right. I mean, obviously you're right about there being a very wide variety of strategic uses for identity signaling. And, you know, the modeling is kind of an attempt to get some handle on that and how it functions socially, but there's always going to be things we leave out. I was really influenced, or I don't know if influenced is the right word, but I was really taken by this book I read last year called Burning Down the House, H-A-U-S, which is this history of punk rock in East Germany in the 1980s, which is where I got that picture earlier on from. It's a really fun, interesting book. And this is, I think it gets at something that's exactly what you're talking about, which is that, you know, in East Germany, punk rockers weren't signaling covertly at all, even though it was extremely costly to present themselves as punks. They would get beat up regularly and arrested by the Stasi very regularly. They couldn't get jobs. So there are real costs to doing this, right? But it was that they felt that being able to form a community of like-minded people that was sort of against the establishment was important enough and worth it, that they were willing to incur these costs. And part of them doing that was it also created visibility for that kind of perspective in a way that would be impossible if it was just presented in a much more subtle or mainstream kind of way. You have to have an overt signal against the establishment in order for people to see what the establishment does to people who are not part of it, or who sort of go against it. And I think that's a really interesting kind of phenomenon that really only exists in the kind of large scale, diverse, hierarchical societies that we live in, and that are, I think, it's unclear to me exactly how historically novel they are. They're, you know, potentially a couple thousand years old, although now technology has really advanced. I think that, like, I'm very, you know, embedded in the sort of theories of cultural evolution, and an issue with those theories is, while I love them and they form a real foundation for the work I do, they're mostly developed to explain and understand pre-industrial kind of hunter-gatherer forager societies, because you know, that's our evolutionary past, and those societies are, I think, have, to some extent, are simpler to explain. They have just fewer moving parts, and we don't have amazing theory to explain cultural evolution in our modern societies. And I think there's so many phenomena that just need to be identified as targets for inquiry and explanation. So yeah, just chipping away.
Perfect. Thank you so much. And I think it's now time to wrap up. I want to thank everyone for excellent and very stimulating discussions. And I will post the chat log in the Slack channel of this group, as usual, so that people get access to think about the issues that were raised that maybe were not directly addressed in the discussion. And finally, I wanted to invite everyone to the open discussion that will happen next week, that will be more distributed, talking about the issues that have been going throughout the workshop on the augmented intelligence broadly construed. So thank you so much.